Good morning guys, I'm Chris and welcome back to another episode of Rift Amps. Morgan AC40 on the bench. I've got it up and running. I've confirmed, it's this side, that the 240 volt switch is wired correctly and the internal voltages are okay. So that side's all good. I haven't got it to make any weird noises yet other than 1, 2, 3, 4, V5, the heater, when you tap it, you can see the heater, the filament is playing up. So I think we've got some dodgy valves there. Anyway, that's the output sine wave. Cut control is at, so I'll put cut control at 0. And 8 ohms, we get about 15 volts RMS, and that puts us about 28 watts. So I don't know if it is down on power. Now it has got this level control thing, power level, which should allow you to dial the power back. Now, I don't think it's working, because here it is at full, and if I roll it down to 0, output remains the same. Look, it's 0. Full, 0. Full, 0. Doesn't seem to be working. Is that our problem? We need to get the voltmeter out and take some more measurements, because something isn't right. Okay, so some progress in that I've had to remove the power scaling from the chassis, and let me show you why. So I've had to draw out the what do you call it? The B plus rail. So we've got the GZ34 rectifier, and then we've got a standby switch, which just a simple make or break. We've got the reservoir cap, 47 microfarad. And then you've got 2 diodes that split off. One of them, so these are 1N4007s, go to the power scaling unit. After there, you've got the output transformer center tap, goes through a choke for the output screens, another node to the phase inverter, and this side, another 1N4007, 10k dropper. Nothing on this node, but this node feeds the preamp. So that's the B plus rail for the AC40. Now, as I showed, whenever you turn the rotary pot, the power scaling pot on the unit, we don't get any change in voltage. But at this point here, we've got 391 volts. Same there. And on the other side, we're getting 335. So it's dropping some volts. So what's going on? So I've removed the unit from the chassis. I've drawn it out. This and this is what we've got. We've got a B plus comes in. Here's your MOSFET. And here's your out. So we've got a voltage drop there. The pot, I've measured everything and everything seems to be okay, but I was getting a strange reading on this Zener diode, but it was only because the MOSFET itself has an internal short, which was confusing the meter. So once we'd removed the MOSFET from the unit, which is an NTE NTE 2973, there she is. That Zener diode started reading correct, and then you can test this separately, and it is indeed shorted. So here is our issue. So got to replace this. Just gone online and ordered one. They are eye-wateringly expensive, so which is a shame, but we'll be able to get all that sorted. All the other components test fine. We'll get that back in, and then we'll be able to retake measurements in the chassis. So I suspect the issue he was having was actually caused by that failing MOSFET. causing all other issues. So the other thing I wanted to do is I need to replace that cathode bypass cap and the grid stoppers on the output valves because they have got hot. Well, you can tell it's post-festival repair season, can't you? Because I've got more stuff coming through the door every day for service and repair. And this thing has just turned up. What do you think it is? Some of you might have guessed already, but if you're not sure, it is a very well worn JMI Vox AC30. Customer, he tells me he bought this very early 1970s, 71 he thinks, and he's had it ever since. He took it to another shop for service and repair and they said no, not our sort of thing, take it to a specialist, so he's brought it here. Now, bit of a disclaimer, for all the vintage amps I get through the door, I don't get a lot of AC30s. Other techs I know seem to be swamped with them, but for some reason, and it's not because I don't specialise them, they just don't really come through my door. It's a strange one. But this one has. So he tells me it's the original Tolex, but he has re-grilled it at some point in its life. So anyway, let's turn it around and I'll show you what we got. So I'm going to have to refresh my memory on AC30s because I know there's lots of different variations, but here we've got 6 input. I think they call it a copper top, don't they? JMI. We look in the back. He tells me late 70s, he replaced the blues because they had blown. He's still got them and they haven't been reconed. He's just left them as they are. And he ordered 2 greenbacks from a shop in London. And they sent him 1 G12M greenback. And I'm guessing this is right on the point that the blackbacks came out because he got one of the new blackbacks. Very cool indeed. So, he said it's just making some weird noises, which when I briefly plugged it in, it sounded like a valve was going. He can't remember ever replacing the valves in this thing. And he said it has got the original transformers as far as he's aware. So, let's get the rear panel off and let's have a look inside. Right, what can we see then? So, first thing I notice is it's an AC30-6, serial number 3082. So we can do some research and look that up. You're looking at this for the first time with me. So I'm looking at this for the first time. Can we see anything obvious? It's got a couple of the Hunt's caps, which we know aren't the most reliable. I mean, if they weren't reliable in radios, they're definitely reliable in guitar amplifiers. But yeah, I can certainly see stuff going on. A couple of cobwebs. But I can't see anything burnt, which is alright. So, he wants me to look at the cause of the noise and service it as required. So we can certainly swap out some of the components that are not good. But yeah, we need to pull the rest of the chassis out to get to the valves and transformers in the back and give it a good looking over. Okay, so chassis is out of the cabinet and I've already shown you the preamp side, and here's the power supply side, the output valves. Still got the single shared common cathode resistor and the bypass caps and things like that. That one's about to pop, look. That one needs swapping. It looks like, we can bring it round this way, we've still got the original Mullard EL84s, the original Brimar GZ34, and the Woden transformers. Very cool indeed. Okay, so that's the AC30. I'm going to go through it. I'll keep you updated as I go along, show you what's going on. But this amp is in dire need of a good old service and a sort out, so that's what we're going to give it. Okay, just an update on the Princeton Reverb. I've done the chassis work. I've mounted the step-down transformer to the side of the cabinet using I've bent some brackets into place, and I've used the existing drilled holes, so I haven't had to drill any more into the side. New 3-prong mains cable, so I've done the mains, a 3-prong conversion inside, and I've given it a play test, just a couple of more tweaks I want to do, but then this amp is pretty much done. So yeah, thumbs up on that one. Give the customer a call. Okay, so back on the Morgan AC40. So just to confirm, the MOSFET, the NT2973, is our suspected failure point. So if I stick it on the tester, press go, comes up with an LED or diode, and look, the blue lead doesn't think the blue lead is connected to anything. So that's the faulty one, and the brand new one that's turned up, we'll connect it up to the tester. We'll run the same test, and it should, there you go, N-channel MOSFET, source, drain and gate all working. There you go. So confirm that the old one was broken, it's faulty, knackered, and we need to get the new one installed and give it a test. Okay, so the new MOSFET is installed, isolator, heat paste, all back in normal, and we are currently measuring the output of that circuit, 377 volts, and as I turn the power scaling down, you can see the output voltage drops. So it's now working as intended. Other way to confirm that is we've got it running on the bench. Do you remember before we measured it about 28 watts? Well, we bring it up now. 17.5, just over 17 puts us somewhere between 36 and 38 watts. So yeah, bang on. And then just if I turn that control, watch the sine wave, you can see the output drops. So it's working again, which is great news. There it is. So I'll just leave that burning in for a bit with a slight bit of power reduction on. That one. Monitor everything, make sure we're happy. Give the customer a call, box it back up. Another job done. That's it then, guys. Thank you very much for watching. It's just all repairs this week. I have been cracking on with the builds, but the repairs have been a bit more interesting, so I thought I'd show those to you instead. So enjoy your weekend. Don't forget to give this video a thumbs up, comments down below, you know the score, and I'll see you all at the next one.